Okay, so here is the spreadsheet example that I have here. Will also be posted on Moodle for you to look at yourself, and you'll get to do this in your homework as well. So this is similar to this is the exact same titration curve we were looking at while we were doing this earlier in the chapter, in earlier videos. Titration of chloride with silver. And again, this is calculated using the equation 7-12 from the textbook, which is what we just derived in the last video. So the inputs that we're going to need, we need to know KSP for our salt that is formed from these two. We need to know initial volume of our chloride solution. We need to know the initial concentration of our chloride solution, 0.1, and what's the concentration of our silver solution, which is 0.05. So this is in the example that we had here. Now you can see here, these values I just entered myself. So these are just, increasing or decreasing, I should say, by 0.1 PAG unit. The concentration of silver, we do need to calculate that, but we can calculate that directly from KSP or directly from PAG, right? So by definition, the concentration of silver comes directly from the PAG value. And chloride, we can use the KSP to figure out, if we know the concentration of silver, we can find the concentration of chloride, right? These are directly related to each other through the KSP. And then this equation here, this is the one that we derived in the last video. This equation 7-12. So this has our initial volume times A8. A8 is our concentration of chloride, plus C4 minus D4, right? These are our concentrations here of what was M and X. And then we have the same thing in the denominator here. And yeah, so if I go ahead and change some of these. Oh, and on the right-hand side here, I have these drawn out as curves. So this is the typical concentration curve we've been looking at, our titration curve. You can see the equivalence point at 50 and the sharp change in the concentration at the equivalence point. This is PAG versus volume, but just to show you what it looks like if we don't plot this in a logarithmic scale, if we don't use the p-value, we essentially have 0 concentration of silver up until we reach the equivalence point, and then it starts increasing quite rapidly. But there is a change in here. It's just really difficult to see on this scale, and so it's a lot clearer on this PAG scale. Okay, now what you'll find when you start working with this is that you won't know what PAG value to start with. Let's say we put in, I don't know, 10. What you'll see here is now my VM changed to negative. And I'm just going to go ahead and delete the rest of this to show you how you would set this up from scratch. Right, and so we see that we have a negative value. What that means is that we need to decrease the PAG value. You kind of have to just try different values to find where you get a VM that is actually equal to 0 instead of the other way around. So if we try 9, okay, it's less negative, but still negative. We try 8. Now it's positive, so we need something less than 8. So then we try like 7.5. Oh, sorry, wrong way. 8.5. That's a little bit better. 8.7. That's pretty close. 8.8. That's too far. So now let's go in between 8.75. And there we go. So we found VM equals 0. You just kind of have to do it by trial and error. And then we can say put 8.8. And a really handy feature in Excel is you can select all of these, and the formulas will copy if you drag with the bottom right corner here. Oh, went the wrong way. That needs to be 8.7. All right, and so now we can see the values are increasing, and we can go 8.6, 8.5. So we can keep doing this. Now, if you have a pattern like this, if you select your values that kind of follow a pattern, and again, this little handle in the bottom right-hand corner will turn to a cross, you can see it's automatically filling that for me as I drag this down. And I can do the same thing with all my formulas here, and it'll automatically calculate it for me. And so you can see it's starting to fill in this titration curve now. We're seeing the equivalence point where the concentration starts changing quite rapidly. And we can keep going here. And you can see it stays at 50 for a large range of PAG values. And that's what it should do because that's our equivalence point. We can just keep dragging this down until we start to get past the equivalence point. So now we're getting like to 54. And now we can see we had that curve like I was showing before. And we could keep extending this further out. Again, this spreadsheet will be available for you to look at and to see exactly how I did this.